Welcome to the Planet of Maths channel. In this episode, we'll be solving absolute value equations. To begin, we have this equation, 2x plus 1 equals 3, the absolute value of x minus 1 plus 2. In examples of this type, we start by taking what's inside the absolute value, which is x minus 1, and setting it equal to 0. It turns out that x is equal to 1. At that point, we'll draw ourselves a number line. On this number line, we then mark that single calculated value. There's just one calculated number. If there were a greater number of absolute values, then these numbers would also have to be more numerous. We mark this one single number in this case and divide the entire number line into two parts. On the left side will be the first part, and on the right side will be the second part. This boundary number, we will always place it to the right into the higher interval because there are two distinct intervals. The first interval will extend from minus infinity up to 1, but without including this specific one. We will then place the number 1 into that second interval. The first scenario is when x falls within the interval from minus infinity to 1. And we need to observe how our absolute value will behave within this particular interval. To determine this, we'll select a number that is certainly present in this interval. For instance, the number 0 is definitely within this range. 0 is included here, and if I were to substitute this 0 for this x, then inside this absolute value expression, I would obtain 0 minus 1, which means I would get the final result of minus 1. This is a negative result, and if we obtain a negative result, then here, instead of this absolute value, I will always write what's inside the parentheses. But if there was a minus sign, we absolutely must change all the signs. So I will now write x as a negative value, and the number 1 I will now write with a plus sign. This is how the signs have been changed here. When I calculate this second interval, where x belongs to the closed interval from 1 to positive infinity, I'll do it on a similar principle. I find a number that falls within this range. Let's pick the number 2 to keep it simple. If I substitute 2 for x, I'll have the operation 2 minus 1, which gives me a positive result of 1. If what's inside this absolute value comes out positive, then I remove the absolute value signs and nothing changes. The expression that is within it stays exactly as it is without any modifications. I will be placing all of this inside parentheses. We need to calculate both these cases now. For the first case, I'll take the example above and replace the absolute value with this parenthesis. No changes for now. And here, after the 3, there was an absolute value. So instead of this absolute value, I'll insert this bracket plus 2. And now I have an equation that I need to solve. I'm solving 3 times negative x is minus 3x. 3 times 1 is positive 3 plus 2. I move x to one side and the numbers to the other side. So we're going to have 2x plus 3x. On the other side, we have 3 plus 2 and minus 1. After we've added these terms together, we'll have 5x equals 4. We divide everything by 5, and the outcome is that x is equal to 4/5. And we must also verify if this number belongs to our specified interval. However, in this case, it is perfectly acceptable. This number belongs to the interval from negative infinity to 1. This number is less than 1. This result is okay. The second case. We've established that this absolute value can simply be replaced with this bracket. So we'll proceed with the very same approach for this case. We're going to solve this. 2x plus 1, that part stays exactly the same. The number 3 also remains unchanged, and instead of the absolute value, we're going to put this bracket and then add 2. We take the 3 and multiply it by the parenthesis. That will give us 3x minus 3. We move all the terms, then we reduce the x's, and on this side we'll have minus 2. We'll divide everything by minus 1 so that we don't have a minus sign with the x. We'll get that x equals 2. This 2 belongs to our interval here, so everything is perfectly fine. X can be equal to 4/5, or alternatively, x can be equal to 2. That concludes our first example. In the second example, we have the absolute value of x minus 4 equals 5 plus 2x. Again, we take what's inside the first absolute value, which is x minus 4, and set it equal to 0. From this, we get that x is equal to 4. We then mark this specific number on the number line and divide the entire number line into two distinct intervals. The first interval extends from negative infinity all the way up to 4, and at the point of 4, it will be an open interval. So this is precisely how our first interval appears. So let's calculate this interval right away. For example, the number 3 is in this interval, and without looking far, 4 is on the boundary, so 3 definitely fits into this interval. What if x is 3? Then the operation here will give me 3 minus 4. It will be a negative number. So this absolute value, I should write it like this, ideally inside parentheses, and the signs here will have to change. I need to write a negative x, and I also need to write a positive 4. And I can now insert this in place of the absolute value, that is, instead of this part. This particular part comes from the absolute value expression. And here we have the remaining part, which is 5 plus 2x. I'm going to remove the parentheses, and then I'll move all the x terms to one side of the equation. We'll then combine the x terms. This will give us minus 3x equals 1. We divide this entire equation by minus 3, and we find that x is equal to minus 1/3. Now we need to check if this result falls within our specified interval. Our interval here is from minus infinity all the way up to 4. Then this number actually fits within this specific range. Therefore, this is a good result. Everything seems to be perfectly fine here. Let's now proceed to our second interval. Our second interval will be from this 4, a closed interval, up to positive infinity, so something like this. In this interval, there is definitely the number 5. We'll take a number not right from the very edge, but quite close to this boundary. The number 5 is not far away. If we were to substitute the number 5 in place of x, then we would get 5 minus 4, which means the result would be 1, and that is a positive result. And if the expression inside is positive, then the absolute value sign is simply removed and nothing at all changes here. So x minus 4, exactly as it was, remains completely unchanged. And now we substitute this into our equation. So x minus 4 instead of the absolute value and 5 plus 2x without any modifications. I'm going to drop the parenthesis, I'll move x to one side, and it turns out that x is equal to minus 9. But minus 9, it doesn't belong to this specific interval here at all. The number minus 9 simply doesn't fit within this range. Therefore, we must reject this particular result. And ultimately, the final solution to our equation will be x equals minus 1/3, because we had to reject that other second result. In example C, it's a bit more challenging because here we're dealing with two absolute values. What we need to do here is to set each of these absolute values equal to 0. From this, we'll get 2, and from this one, we'll get x equal to minus 3. And now we must mark these two specific numbers on our number line, minus 3 and 2. And then as a result, our entire number line gets divided into 3 distinct intervals. The first of these intervals is from negative infinity up to the value of negative 3, but without including the number 3. And we'll calculate. Let's first consider this specific value, x minus 2. The number minus 4 definitely belongs right here. So in place of x, we're going to substitute that minus 4, and then we'll figure out exactly what the outcome will be. Minus 4 subtracted by 2, that ultimately results in minus 6. Therefore, what we have here is a negative result. If it's a negative value, then inside the parentheses, we need to write everything with the signs reversed. So that's negative x plus 2. Now we're going to take a look at the second absolute value. That's the absolute value of x plus 3. X here could be negative 4, so we've taken that negative 4. Now let's calculate. Negative 4 plus 3 gives us negative 1, meaning the result is again negative. And that means we'll replace this value with what was inside here, but with the signs changed. It will be negative x minus 3. So these are the absolute values, and we'll substitute them into the equation above. The first absolute value is our first parenthesis. Then we add the second absolute value, which is this, and this equals 3. We calculate this quickly, remove the parentheses, and move the 2 and 3 to the other side. We determine that x is equal to minus 2. Now we must verify whether this particular number, minus 2, actually belongs to our designated interval. And it becomes clear that it absolutely does not belong to this specific interval. Therefore, we are compelled to reject it. Now the second interval, this central interval, which extends from minus 3 to 2. However, at the point of minus 3, this interval will be closed, and at 2, it will be open. Let's consider a number that most certainly belongs to this specific interval. Here, it definitely has to be 0. 0 is an easy number for calculations, and instead of x, we substitute 0 into the first absolute value. 0 minus 2 gives us minus 2. So the result is negative, and since the result is negative, it means we need to change these signs here. It will be a negative x and a positive 2. Proceeding in exactly the same way with this second absolute value. Instead of x, we're going to substitute number 0. We have 0 plus 3, which is 3, a positive number. So we simply drop this absolute value and no signs will be altered. This is what we are left with, and then we will calculate. Instead of the first absolute value, we will use this bracket. Then we need to add the second absolute value, which is the second set of brackets, and this is equal to 3. Here, the x terms cancel each other out completely, and what I'm left with is that 5 is equal to 3, and that is evidently untrue. This, of course, is a contradiction. In the first interval, we did find a result, but it had to be rejected. In the second interval, we didn't find any result whatsoever. Here, a contradiction emerged, so we are left with this third interval from 2 to positive infinity. This is that interval. In this interval, there is the number 3. Instead of x, we'll put a 3 here. That gives us 3 minus 2. We get a positive 1, which means we're in the positive. So the first absolute value, it doesn't change its form at all. It simply transforms into a regular parenthesis. Now for the second absolute value, if we substitute the variable x with the number 3, then the result will be 6 after the addition, and it will also be a positive 6. So we'll just copy this bracket as well, and the expression inside won't change. The content within it is exactly the same as what's here. We already know that instead of the first value, we'll use the first bracket, and instead of the second value, we'll use the second bracket. Then we calculate it exactly as we did before. We remove the brackets, keep x's, move the numbers, and we get x equals 1. But this result of 1 should again fall within our third interval, which we are checking, and it doesn't fit here at all because the interval is from 2 to plus infinity, so we must reject this as well. So we end up with no solutions because in the first, the second, and third case, the results that came out either had to be rejected or no result was found at all. So in other words, we could say that this is an inconsistent equation. We have 2 more examples left. Example D. Again, 2 absolute values, but this will be a bit worse as there's a minus between them. The method is very similar. We first equate the first and second values to 0. Here we'll get 4, and here we'll get 1. These are our 2 numbers, the number 4 and the number 1. We're going to mark them on the number line, the 1 first, then the 4. The entire number line is divided into 3 distinct intervals. We will address each of them in sequence. First, we have the initial interval, which extends from negative infinity up to the number 1. This represents our very first segment, and the number 0 is included within this particular interval. 0 is close to 1. 0 is quite easy to calculate with. Instead of x, we have the absolute value of x minus 4. If we substitute 0 in here, then we will get 0 minus 4. The result we get from that is minus 4. A negative result means that inside the parentheses, we will write this expression, but with all the signs changed, negative x plus 4. In the second absolute value, we need to substitute 0 for x. We will have 1 minus 0. That's 1, and it's a positive 1. So the second absolute value won't change at all. It will be 1 minus x, and we insert this into the current operation. First, we have the absolute value of the first term within the parentheses. Then we subtract whatever is inside that second absolute value, which is this here. And all of that comes out to be 2. We remove the parentheses. The x terms cancel out again. It turns out that 3 is equal to 2. Well, and this is a contradiction. So there is nothing from this first interval here. We take the second interval, which is closed from 1 to 4, open. This is our second interval. In this interval, for example, we have the number 2. If we substitute 2 for x, we'll get 2 minus 4. This is a negative result, so we'll put all of this in parentheses, but the signs need to be changed. There will be a negative x and a positive 4. In the second absolute value, instead of x, we must again substitute that number 2, which we previously selected. Then we have 1 minus 2, and that equals minus 1, which is once again a negative result. And when the result is negative, the signs change, so it becomes minus 1 plus x. We then substitute this expression in place of our absolute values. The first absolute value is this. Subtract the second absolute value, and this whole thing equals 2. We remove the parentheses, keep x, and move the numbers. This gives us 3 halves, and we must check if it falls within our interval. However, 3 halves, or 1.5, fits into this interval, so it's fine. That's a good result. We still have a third interval, the closed interval from 4 to positive infinity. Certainly, the number 5 is included in this interval. Instead of x for our very first value, we're going to use the number 5. We will then have 5 minus 4, which gives us 1, and because this is a positive 1, we can simply disregard this entire part, and absolutely nothing inside will change. Now here, if we substitute 5 for x, then we'll have 1 minus 5. This is a negative result, meaning the second absolute value must change signs. It'll be minus 1 and it'll be plus x. And now we can substitute this into the equation. Instead of the first absolute value, the first parenthesis, minus, instead of the second absolute value, the second parenthesis. We remove the parentheses. Here the x's cancel out, and I'll get minus 3 equals 2, which is a contradiction. From the third interval, there are no solutions. Therefore, the answer to our problem is what we got in the second case. In the second case, we got the result 3/2. This is our solution. And our final example. We also have two absolute values here, so we'll calculate them. This will be equal to 0. Then x will be equal to negative 2. Here we will find x to be equal to 5. We then place these two specific numbers onto the number line. The number line then divides itself into these three distinct sections. The first section will be the interval extending from negative infinity all the way up to negative 2. This is our very first interval. For instance, within this particular interval, we have the number negative 3. If we substitute minus 3 for x in the first absolute value, we'll get minus 3 plus 2. That's minus 1. So this absolute value is negative. Therefore, we need to change the signs. Negative x, negative 2. We also substitute this minus 3 into the second absolute value expression. And then we have minus 3 minus 5, which gives us minus 8. This absolute value is also negative, so we must change the signs inside the parentheses here. The x will become negative and the 5 will become positive. Now we can proceed to insert this into our example. We'll begin with the first absolute value, and in its stead we will place this bracket. Then we subtract what's inside that second absolute value, which is this expression, and all of this will be equal to 7. We drop the parentheses once again, and the x terms will cancel each other out. It turns out that minus 7 is equal to positive 7. This is, of course, a clear contradiction. So from the first interval, we don't find any solution. Now the second interval from minus 2 to 5 has a closed endpoint at minus 2. The number 0 is definitely in this interval. We substitute 0 for x, which gives us 0 plus 2. This is a positive result, so inside the parentheses it will be exactly as it was with no changes. And in the second absolute value, if we put 0 for x, we'll get 0 minus 5, which is minus 5. The result is negative, so in this case we need to change the signs. It's going to be minus x plus 5. And then we substitute this into this particular equation. Instead of the first absolute value expression, we'll use a parenthesis where nothing has been altered. Then we have the minus of the second absolute value, which is this expression here. This is then equal to that specific number 7. We proceed by removing the parentheses, then we simplify the equation, and from this we find that x is equal to 5. Now we check if 5 belongs to our interval. Our interval is from closed negative 2 to 5, meaning it includes negative 2 but not 5. This means that this result does not belong to this interval, so we must reject it. From the first scenario, we have nothing for now. From the second scenario, we have nothing for now. Let's check the third interval. The third interval was from 5 closed up to positive infinity. The number 6 definitely fits within this range. 6 plus 2 is a positive result, so we'll place what was inside the parentheses without any changes. Here, if we substitute 6 for x, we'll get 6 minus 5, which will result in a positive 1. So nothing will change within the parentheses either. And we substitute this into our example above. The first absolute value is x plus 2, minus the second absolute value is x minus 5. This equals 7. We drop the absolute values, the x's cancel out. Only 2 plus 5 remains, so 7 equals 7. And something like this is what we call an identity, which means at this very moment we have an identity equation. An identity equation means that any number satisfies it, but in this particular case, it's any number provided it falls within this specific interval. Therefore, the solution here won't be just a single number, nor will it be two numbers. Instead, the solution will be an entire interval. X will belong to the interval from 5 closed to positive infinity. That's all for this video. Thank you for watching and invite you to watch the next episodes on the Planet of Maths channel.